These are N5ESE diodes, germanium diodes, which I plan to use for my N5ESE Classic RF Probe. Earlier I had used N5ESE because they were available in my store. Secondly, this one, that is N5ESE, was not available in the local shops. But now I have been able to buy these online. The advantage is that these have a lower barrier potential or forward voltage of about 0.25 volts. That means they will be able to measure lower RF voltages, especially in the driver segments of the RF amplifier. The diode which I had used would have a barrier potential of about 0.7 volts. On the other hand, the maximum RF voltage these diodes N5ESE can measure is around 40 or 50 volts, because that is the reverse breakdown voltage, while the previous one would have had a slightly higher reverse breakdown voltage, so that higher RF voltages could have been measured. Anyway, as it is N5ESE probe, I thought I'll go by the original description, as the components are now available with me. Here I have chosen the diode testing mode in the multimeter, and the diode has been connected here, and you can read the value 0.254. that is the value 0.254. It corresponds to the 0.25 which I mentioned initially. I have reversed the polarity of the diode so that you can see it is out of limit. That's because there is no reverse conduction in the diode. For a comparison, this is the popular rectifier diode N5ESE, and it shows a barrier voltage of 0.55 volts, almost more than double that of N5ESE germanium diode. This is a silicon diode. This is the N5ESE diode which I had taken out from the N5ESE probe. It has a barrier potential of 0.557. Interestingly, not all N5ESE have the same barrier voltage. This one has a higher barrier voltage of 0.41. On the other hand, this one, there is no conduction at all. This is a defective one in the pack of 4 which I bought. Actually, I lost the one which I had tested as 0.5 volt, and I took another one and mounted, and that has 0.282 barrier potential. So such a lot of variation in a pack of 4.